Okay. Coding seems to have started. Okay, let's move on. Let's see a simple requirement, right? So this is the requirement on the screen, which we'll build. It's a very simple thing. Given a number, your client comes to you and says that given a number, you have to find out the next prime number after n. Okay, so for example, if n is equals to 8, then the next prime is 11. If n is equals to 11, then next prime is 13. If n is 14, then next prime is 17, right? So I hope this requirement is quite clear to us, right? Any doubt in this? Because we are going to build everything on top of this now. Is this clear to everyone?
Yes.
Okay.
Yes.
Okay, so let's move on. I'll open up my IntelliJ to create a new project. And let me just, yeah, simple. This is the location. This is the project name. I'm choosing the language to be Java and build system right now. Since this is just the Hello World program, I'm just choosing IntelliJ. So it's a pretty straightforward Hello World program that IntelliJ will itself create and give it to us. Okay, so here it is. So this gives us Hello World program. I'll just run it to verify that things are all working fine. And yeah, it prints hello world, right? So now we'll start building from here. Okay. So we know that in the main method, the input comes from Rx, right? Let's get that input from here. And let's say that this is the input, right? And we need to convert it because it is in the form of string. Okay. And what we need to do is we need to check, then we need to find out the next prime, right? So number to check is input plus 1. And then we can have a loop where we can simply say until is not prime. I keep on incrementing this, right? And in the end, I just print out the number. We need to have this is prime method. Here is your is prime method. Okay, so this simple straightforward logic where this method accepts a number. We run a loop from 1 to that number itself. And this loop is driven by this variable I. And every time the I is able to divide that number, we increment the counter. In the last, we check if the counter is 2. That means it was divisible by itself and by 1 only. And that means it's a prime number. Then we return a true. Otherwise we return a false. Right? So that's the simple logic. And this is the simple program. Right? I hope this much is clear because this is pretty straightforward. No, are there any doubts in this logic so far?
No, it's clear.
Okay. Okay, fine. So let's move on. Let's run this and see what it gives. Okay, obviously it will give an exception because we did not supply any input to it, right? So the way to do it is we can edit the configuration. Here you can supply. So whatever you supply over here in the program arguments in the IntelliJ, that actually gets caught over here. Okay, so let me supply 12 or 13. Okay, so the next prime to 13 it should print and run it. Uh, Say debug. Yeah, it is giving 17, right? So it's working fine. Okay. So this application is working fine. Now, the thing is, there is a small problem with this application. We actually cannot go to the client and say that whatever you have told, we have built it, and here it is, take it and find out your next prime. Because we are giving the overhead to them to install Java, to install Java development kit, and then run this program, right? So this is now, this is not how it would work for the client, right? So what okay, so let me explain it in this way. So right now what we have is we have a logic. Okay, we have built the logic in the public static void main, right? And when we ran it, what actually happened is a JVM came up, which actually ran that logic, right? And when the JVM came up, it allowed us basically, to accept an input and then produce the output. Right? So this is what happened. But once the output was produced, the JVM was gone. That was out of the picture, and we were just left with this logic only, right? So this kind of architecture definitely is not going to work for our client, right? So what they want is they want that we should have some kind of application inside which we should have that logic, and they will supply the input sitting from some other machine, their machine, to your machine where this logic is hosted, and they should be able to get the output. Right? So to do that, what we need to do is we need to take our logic and put it inside a server. Okay, so now the question might be what's a server, right? So server is a special software that comes to you that says that hey, you have written the logic to find the next prime, but I'm a special software which can always keep the JVM up and running. So in other words, I can always host your logic on the machine where I am running, and I understand the protocols which work on the network. That is, your client wants to request or send an input over the network and execute this logic. So I can help you do that. I can actually help you accept a request on the network from your client, and then I'll execute your logic, and whatever output I get out of your logic, I'll just supply it back. So I am that kind of a software. So that's what a server in general does, right? So once we put this logic inside a server, and don't worry how we put it, we'll see in a short while how we are going to do it with Spring Boot and everything. So we put it like this. And once we have this, then the JVM will always be up and running, and your client can anytime send a request and get an output back. Okay. So Spring Boot comes over here and says that I can help you achieve this architecture where you just need to build your logic and I can run the server for you. And Spring Boot can actually do a lot of other stuff as well. It actually helps us, reduce a lot of boilerplate code. So if you know how to connect to a DB and get some data back, years back we used to use JDBC, right? But now Spring Boot is there and it provides you uh, a very very short kind of a code you have to just introduce with Spring Boot and you will be able to interact with the DB. So it basically helps you do the development very fast, right? So it sets up this architecture also, and it lets you do your development also very fast. One aspect of it is dependency injection, which we will see today. So yeah, so now the next what I'll do is I will just port the logic. I'll move the logic which I have written on public static void main to Spring Boot application. Okay, so are there any doubts up to here?
No.
So now we will create a new project. Okay, and this time we can call it as next prime or something, prime finder. And then we say that the language is Java. Build system, I'm going to choose Maven. So build system is nothing but, it lets you download the dependency. So for example, Spring Boot is a library or a framework, right? There are some sets of files, Java files, which Spring Boot is having, right? So we need to get those files in our project so that we can use them in our project, right? So Maven or Gradle, whatever you have in your org, you can use it, and I'm using it. I'm using Maven right now to download those Spring Boot dependencies. Okay, so I'll create project from this. So the project has been created, and as you see, like before, it has just given me a hello world over here. Now let me just rename it to say application. Okay. And first thing that we want to do is download Spring Boot dependencies, right? So we go to this pom.xml. So this is given to us by Maven, and we need to specify the dependencies over here, right? So I've just specified the dependencies. We declare the dependencies here. We just need these dependencies from the Spring Boot, right? And this is the way of declaration. Now the second step is downloading them, right? So we need to use Maven to download those dependencies, which I will do now. We need to say Maven install. Okay, so dependencies are downloaded. Actually, on my machine already, the dependencies are present, so it did not take a long time. Otherwise, it generally takes 20 to 30 seconds to download these many dependencies. After you are done downloading the dependencies, I can come to the IntelliJ just to refresh this so that IntelliJ is also aware of all those dependencies. Okay, so we have downloaded the dependencies. Now we need to build our Spring Boot application. Okay. So first off, we should come here and annotate it with Spring Boot application. And I'll explain what all this means in a short while. Okay, so this is just imagine that it's just some boilerplate code that we always need to write, and what it means I'll explain in a short while. So this is the starting point. After I run this, it would start the Spring Boot application. Now we need to create an API, right? Where we should write that logic which I showed you earlier. So let me create a package called code, and inside this we will be writing all the logic, all the APIs which we have, right? So let's name it as controller. This has to be annotated with the REST controller. So this is an indication to the Spring Boot that this is the class where I'll be exposing my APIs. Okay. So now what we need to do is we need to basically get to that. Yeah, we need to port all this logic, right? So I'll just copy this whole thing over here. We need to do some modifications. So for example, ours is not going to be static method. It's not main method as well. We can call it something else. Main will also work, but let's give it a meaningful name. And next fine. And the input will not come like this, like, right? So we can take the input from here. Okay, so this is the method which we have quoted over here, right? Now we need to expose this method as an API. So we need to use one annotation. Sorry, request mapping and say, okay. And this should come as a query param. So let's say mix up a query param with this. Okay. So now what this all means, let me just explain. So this over here, whatever class is annotated with the REST controller, this is an indication to the Spring Boot that over here the APIs would be defined, and how the APIs would be defined with this annotation, which is request mapping. The identifier that you see over here, basically we call it sometimes as API or we call it sometimes as endpoint. Okay, so this is the API or the endpoint that we have exposed, right? Which is find prime. So basically, there is a REST API now which is exposed now, and this can be invoked. We'll invoke this in a short while. And when we invoke, somebody invokes this, then they can pass a query param with input, and that would be mapped over here. That input would come and would be passed to this method, and this method would execute, right? So this is how things are there. So I hope the annotations and the things in this class at least are clear, so that now I can move on to the application class to explain what those things are. Is this much clear?
Yeah. So the endpoint which you call here,
Yes.
this would be a public endpoint, like
Yes,
accessible.
yes. Yeah, yeah,
Okay.
yeah. So we are going to invoke this in a short while. This will be
Okay.
public endpoint.
Okay.
Okay. And anything else from anyone? Okay. So moving on to this application class, right? So what is this class? So basically, as I told that with this line, we are actually launching the Spring Boot application. And what we are passing here is application.class. In other words, we are actually passing the location of this class itself, because application.class itself carries the fully qualified name of this class, right? So in other words, we are launching the Spring Boot app and we are saying that note down a location of this class, and where this class stays in org.example. This is the package. right? This is the location of this class. So what the Spring Boot is going to do with this location? So Spring Boot will note this location, register it with itself, and say that, okay, fine, I am now going to scan this location which you have passed to me, and I am also going to scan all the child packages which would stay in this location. So you see, one of the child package that we had created was code, right? So it is also going to scan everything in this package as well. Okay. So what kind of scanning it would do? It would actually scan all the source code that we are writing and see what kind of annotation we are using. So we are using REST controller, we are using REST mapping, right? So they are various kinds of indications to the Spring Boot to do certain things. For example, this and this tells the Spring to expose this as an API, right? So to do that task, Spring Boot has to do something, interact with the server and do certain stuff, right? So it would scan this class. It would be only able to scan this class if this class is present under this location, right? So is this clear? So I'll now go and invoke this. So how you can run is you come to this application, right click, you can click on run or debug. Okay. And when you ran, if you see over here in the logs, Tomcat started, a server has started. So Spring Boot has an embedded server. It starts and your application is now available and can be accessed, right? So just like a RESTful API can be invoked in a similar way, this can also be invoked. So we can actually say localhost 8080, and then we can say find prime, and we can pass it some input. Simulation 17. Okay, I think what we did is in our example, if you see our method is not returning anything, it is printing. So it printed over here. We don't want to print like this because our client would be very unhappy because they did not get the output back, right? So we need to return this and we need to put over here integer. Okay. I will restart the server. I'll stop and restart because if you do these kinds of changes, server needs to be restarted. So Spring Boot application basically is restarted so that the server also restarted. And now if I go over here and invoke this, you see we have got the next prime, right? You can pass any other number as well. You will get the next prime, right? So this is how we are exposing. So I hope this kind of a thing is clear to you. So how we actually target this API is we specify first of all which computer you want to reach. Localhost currently points to my own laptop, my own machine. And this means that this kind of a request means that first of all, go to this computer and over there you will find a server which would be running on port 8080, and over there, inside the server, there would be an endpoint which would be exposed, which would be identified this with this find prime. And that endpoint would be accepting a query param. So I'm supplying that. And in that way, go and hit that endpoint, pass this input and get the output back. Okay, so this much is clear, this invocation which we did.
Where is this pretty print coming from?
I think it is something related to browser, or I'm also
Oh,
not sure. It has nothing to do with Spring Boot.
okay.
So this output is a JSON or is it just
No.
a text?
Right. Yeah, right now, as you see that we are simply, passing it back as integer, right? So it should be
Mhm.
plain text only. It's not a
Okay.
JSON. In
Okay.
this, we will not deal with JSON.
Okay.
That's a separate thing.
Okay.
Okay. Anything, any other questions? Okay. So now let's understand what is actually happening on the Spring Boot side. Okay. So as you have seen that there is a controller, right? And every time we invoke this request, this method gets called, right? So just to let you know, Spring Boot actually what it is doing when it is starting up, right? Then it is creating an instance of this class. Okay, singleton instance. Singleton instance, I hope is clear to everyone. Singleton instance, by singleton instance, what I mean is it creates its instance only once and that instance it maintains in the memory. It does not recreates it every time when you send a request. And we will see it, we'll prove it here. So let me introduce a constructor over here. So if Spring Boot is creating an instance of this class, it must be using constructor, right? So I have introduced a constructor, and let me print something. That constructor is called. Okay. Now, if I restart the application, you would see, you see here constructor is called. This means that on the startup, Spring Boot creates an instance of this. Now, the second thing that I said is that it would always have a singleton instance, right? To verify that, let me go ahead and introduce a system of println over here and say, I'll just print out this object, right? So if it is the same object, every time we should get the same string printed. Let me show you. So on startup, you see constructor is called. That means this constructor got called, right? And now I will start sending some requests. So let me send this request. Let me send one more request. Let me send one more request. So three times that method got invoked, right? And three times the object name got printed, and it is same all over, right? So it means that Spring Boot on the backend is creating just a single instance of this class. And every time we send a request, it invokes this find next method on that singleton instance every time. Okay. So I hope this much is clear that what's happening on the backend, how object is created and how it is. Is this clear? Everybody agrees?
Yeah.
Okay. So I'll just remove this on. Okay. One more thing I wanted to share is that there is this REST controller. If you go inside this, now you do not need to understand how you define controllers or how to create and how Spring Boot has created. But I just want to let you know a theory that REST controller inherently is basically a component controller. Okay. In other words, what I mean is that when you write at the rate REST controller, there is this kind of a annotation which is present inside this. So this annotation actually kind of inherits this annotation in a way. And when that happens, Spring Boot would do certain things. I told you, right, that based on certain annotations, Spring Boot does certain things. So when Spring Boot sees this annotation at the rate component, it creates always a single instance of that class and maintains it in the memory. Okay, so this is why it was creating a singleton instance. That's what I wanted to clarify, that this was an indication to Spring Boot to create an instance of this class and a singleton instance. And that happened because this was implicitly annotated with at the rate component annotation. Okay, is this much theory clear?
Yeah.
Okay, okay. Now let's move on. Mm, second. Uh, So we are now going to see that how dependency injection is going to work. So it's going to start from here. Don't worry what it is and how it works. We'll just slowly and slowly see. Okay. So suppose you have written this code, right? And it is working fine in the production, but your colleague comes in and says that, hey, this is a controller class where you have an API. In future, we are going to add more APIs to this, right? So it would be better that this logic part that you have written over here, you can extract this out to a separate class, move it out to a separate class, and just invoke that method from here, right? So that way, the public endpoints at least, they looking quite clear in terms of readability. Okay, so it perfectly makes sense that yeah, for the sake of cleanliness, we can actually move all this to a separate class somewhere, some kind of service class or something, right? So let's create that class. Say prime finder. Okay. And we need to port all this logic. So we can say a public method over here, which returns an integer, say find, and it takes an input. That's it. So what I'll do, I'll copy all this, cut this from here and paste this, and take this also in the other class. Okay, so new class has been created and all the logic is ported over there. Okay, now what we need to do is we need to just invoke that class, right? So we say that I create an instance and I invoke a method which is there and I just pass this input. Right, done. So all I've done is I have actually just segregated out that logic. So that way this endpoint is looking quite clear. And in future, if there are more endpoints, everything we can see in one go. Right. So let me restart the server. Should work because we have not done much. Yeah. So you see, I'm able to invoke requests. It's working fine. Right. Okay. Now coming back to this code. Now, there is a small problem in this. What we are doing is every time a request comes to us, we are creating an instance, which is Prime Finder, and then we are invoking a method, right? So your colleague again comes to you and says that why are we creating an instance every time? Why can't we do it in a way where we just have this instance only once created and you use that instance every time, right? So that also perfectly makes sense, right? So what you do is you take this out from here and you have it as instance variable, right? So this approach should also work, right? Because at the startup, when a singleton instance gets created of entry controller, at that time only, this would get instantiated and this would happen only once. And that way we will have just a single instance of Prime Finder and we are invoking a method on that, right? So this kind of a refactoring makes sense. Now, again, there is again a certain small problem with this. The best practice actually is to instantiate objects inside a constructor, right? So what I mean is, if you have a constructor over here, one second, I have a constructor over here, yeah, of this, you can say, I'll instantiate it here instead of here. That's it. That looks most formal approach, right? That whenever an instance of entry controller is created on the startup, and we know that Spring Boot would create this at startup, then inside this, I will also create a Prime Finder object, and it will be ready with us. And on the runtime, when a request comes to us, we will invoke that, right? So I hope this much refactoring is okay. Yeah, this was simple refactoring. And if I again go and yeah. So if you see, it's working fine. We have just done that refactoring. It's all working fine. Now here comes Spring Boot, and Spring Boot says that you don't even need to do this, right? Whatever instances have to be created, you let me do it. Okay. So what we are saying is that instead of we creating this instance over here, we ask Spring Boot to do so. How can that be done? That's a two-step process. One, we go to this class and we say at the rate component. So I told you already, right, that the class which are annotated with component, Spring Boot will create a singleton instance of those classes and keep it inside the memory, right? So with this, we are telling Spring Boot that the Spring Boot should create an instance of this class. Okay. Now coming back to entry controller. Over here, the instance which is created by Spring Boot, we need to accept that. We don't need to, create it ourselves, right? So how to accept that? That's the step number 2. So what you can do is you can actually accept that instance over here, which is created by Spring Boot inside this constructor only and assign it like this. Yeah. And say auto wired. Okay. So over here, what we are saying is we are saying Auto wire means there are some arguments which are present in this constructor. Go and create the instances of those and provide me here. And once it is provided, I will assign that to my instance variable and I'll go ahead and use those. So if you see, in a way, we have asked Spring to create an instance and provide it to us, right? This mechanism of asking someone else, asking some kind of a framework. Here we are using Spring Boot. There are various kinds of other frameworks as well. The process of letting the framework do the dependency work, that is creating the dependency, this is called as dependency injection. So this process itself is called as dependency injection. We have not created the instance ourselves. We have asked Spring to do so, right? So that's the terminology. And there are various kinds of associated terminologies also. I'll just explain in a short while, but let me just restart and run it to see if things are working. Over here, if you go, yeah, it's working all right, right? So there are various kinds of terminologies associated to dependency injection, right? So I'll just go and cover those quickly, which I have on PPT as well.
One question here. So
Yeah,
in the life cycle, first the object of the controller is created, and
I'll
then
explain.
yeah,
Yeah,
okay.
I basically, so this is just one level of dependency that I'm showing. I will
Mhm.
extend this to two level and then I have a plan to explain the life cycle. That is the step-by-step things that happen inside.
Okay.
So
Okay.
then things would be more clear.
Mhm.
Okay. So yeah, so these are the terminologies. So what is dependency injection? Dependency injection is a process of asking somebody else to create the dependent objects and inject it. Okay. Over here in this class is called as dependent because this is dependent on prime finder, right? So entry controller is dependent. So this is called as dependent class. And this prime finder is called as dependency. Okay. This is dependent because to do work, to basically execute this method, it actually depends on this class, right? So that's why this is called as dependency and this is called as dependent. And dependency injection, I just explained. Inversion of control is just the synonym of dependency injection. Okay, so those two are pretty much the same thing. Okay, and IOC container and application context. Again, these two are synonymous. What they mean? This is, you can say, framework inside the Spring Boot or module of the Spring Boot or sub module of the Spring Boot, which is responsible to do dependency injection, which actually provides you this way of creating the object and injecting it to your own objects, right? So that sub module or the framework inside is called as IOC container or application context. Do not confuse with container. Some people think that container is a space inside which objects are created. No, in Java, objects are created on the heap, right? So IOC container is just that framework inside the Spring, which allows us to do dependency injection. And what are beans? Beans, we refer to the objects, those objects only. So for example, here in our application, an object of this entity controller got created and an object of prime finder got created, right? So these are called as beans. We have a bean of entity controller and we have a bean of prime finder. Okay. So is this much clear to everyone? Anishka, Samta, any questions?
No, I'm good.
Okay, yeah. If at all there is any kind of question, please ask because that would make things more clear.
Uh,
Uh,
One
yeah,
thing, sorry.
yeah,
Container is just nothing, just a framework, nothing else, right?
yeah. Controller. Yeah, you are asking about this.
Container, IOC container.
Oh, IOC content. Yeah, yeah. That is a kind of a framework or a module inside Spring which is responsible to do dependency injection.
Okay, okay.
So these are
Basic
yeah,
context is something that is provided by the container.
yeah, yeah. So these two are synonymously used. most of the times. And application context we say because there is a context which Spring Boot has created inside which there are objects, right? So that we call as application context, and we also call it as obviously container as well. I just explained those because these are most popular interview questions. So
Mhm.
if you are giving, you can answer. If you are taking, you can ask.
Okay, thanks.
So this is all about, yeah. So what I'm showing right now here is one level of dependency injection. Okay. So what you saw over here is that there was a class entry controller inside this prime finder was present, right? Now I'm going to show you now two level of dependency injection. Let's go there. Let's go to prime finder. Now again, your colleague comes and says that, hey, this is prime method, right? This is very much kind of reusable, which could be used in a separate part of the application as well, right? So he's saying that maybe you can move this also to a separate class, which also makes sense and invoke that, right? So we are again going to do the same thing which we did earlier. Right now, we will just create a class which is, let's say, is prime, which will check whether a number is prime or not, right? It would have this method. I'll just move this here as a public method, and it returns true or false. And over here, again, we need to basically inject that and use that, right? So remember what is the two-step process? One, we go to is prime, right? We create we say that it's a component. So it's an indication to the Spring Boot that it has to create an instance of is prime, right? And second, we can, we first of all should have some kind of instance variable, and then we can have a constructor or void, and then we invoke that method. That's it. Okay. So is this much clear? We have done the same thing, but inside this class as well. So over here we are saying that is prime. We are letting Spring inject it over here or letting Spring provide us over here. Okay, so this is the same thing that I've done earlier. So if you see now, it's a two level of dependency injection. In entry controller, prime finder gets injected, and in prime finder is prime gets injected. Now I'll explain you the life cycle which Karthik has asked. Then things will be more clear that in what a sequence of order happens on the backend. But first, let's just restart and verify if things are working. Okay, yeah, it's working fine. Okay. Now let me just explain what happens on the runtime. Split and move it to right, and then have this prime also. Split and move to right. Okay. Okay, there is one more thing. I hope this is known to you that if you look at this as prime, if there is no constructor here, then Java actually introduces a default constructor which looks like this. So even if I don't write this, implicitly behind the scene, Java has written this for us. Okay, so this is just a Java thing. So for more clarity, I am going to write this over here. Okay, and then I'll explain what happens on the backend. So uh, so I hope these three classes are kind of visible. The whole code is not visible to you, but all we need to make sure is that their constructors are visible to you. Okay, yeah, their constructors are visible to you. So what I'll do, I will take a snapshot of this. I will go to the whiteboard and explain you what happens. Let me maximize this a bit. Yeah. Okay. Okay. So on the startup, what happens? On the startup, first of all, Spring comes over here, says, okay, this is REST controller, and this implicitly is a at the rate component, right? So this is an indication to the Spring Boot that it has to create a instance of it, a singleton instance, right? So to create an instance, what would one do? It would actually go to its constructor, right? So it goes to its constructor over here. In the constructor, it sees that, okay, there is some other object which is needed over here. Okay. And once this object is available over here, then only I can go and run the constructor, right? Then only the object of entry controller would be created, right? So as soon as it sees that there is a dependency over here, and first that needs to be created, then Spring Boot stops here. Spring Boot says that, I cannot go and basically execute this constructor because there is a dependency. And first of all, the object of that dependency needs to be created, right? So to do that, Spring Boot goes to this class and says that, okay, there is an indication over here. And this is an indication to me that I should create a singleton instance of this. To do that, it would go to the constructor of prime finder, right? So it goes there. Now over here, it says that, oh my God, there is another dependency which it depends on, right? So I cannot literally run this constructor until the instance of is prime is available, right? So it stops there for a while and then it goes to is prime. Okay. Over here, it sees that there is a component annotation here. That means it's an indication to me I can go ahead and create an instance. Then it goes to its constructor to create its instance. It says that there is no dependency over here. So I can execute this constructor, right? So it executes this constructor. And as soon as a constructor finishes, what you have an instance, right? So as soon as this constructor finishes, there is an instance of is prime class, which got created, right? So once that is created, Spring Boot says, let me take that object and go back and let me supply it here. Then it supplies that object here. Okay. Now Spring Boot says, since this object now is available, I can now go and execute this constructor. So it goes ahead and executes this constructor. At the execution end of this constructor, what do you have? You have an object of prime finder, right? So once it creates an object of prime finder, it says, let me take that object and go back and inject it over here. Right? So it provides it there, it injects it over there. Once it provides it over there, then Spring says, now I can also go and execute this constructor as well. And it goes ahead and executes this. And at the end of this, what you have? You have an instance of entry controller, right? So in this way, the object of these classes get created. So is this life cycle clear to everyone? Karthik, you had asked,
Yeah.
so
Yeah, I got it. Yeah.
yeah. Samta, Anishka, anything?
Yeah, it's clear.
Okay. Okay, fine. So let me now go back to IntelliJ and we have more to cover. Okay. So now what I will do is see, there's a two-level dependency injection going on, right? So or in between these two classes and then between these two classes, right? So going forward, what I will do, I will actually, do certain things differently between prime finder and is prime so that is prime gets injected in different ways in the prime finder. I will not touch entry controller. So whatever is happening between these two would remain same. That means how prime finder is getting injected over here, it would remain same, but I would alter some ways between prime finder and is prime. Okay. So with that being said, I'll close this entry controller. So, yeah.
Hello, sir.
So yeah.
Uh, could you please explain that if REST component inherits from component annotation, then what is the difference between using like annotation component and annotation REST controller?
Okay.
I
Yeah.
mean, what
Yeah. Got it.
difference that REST controller makes that we are using REST
Got
controller
it.
instead of component?
Yeah, got it, got it. So basically, every kind of annotation is an indication to the Spring Boot, right? So I said that it implicitly is a component. So that is an indication that it should create a singleton instance of this entry controller, right? That's one. Other thing is REST controller has got something more than component. So just like in a class, right? When you extend, if there is a class A and if you say class B extends A, right? Then you add certain functionalities on top of it, right? So in a similar way, REST controller is is adding something on top of component. It's an additional indication to Spring Boot that you have to create a singleton instance, but you also have to expose the APIs which are present inside this with request mapping. So that is the extra indication that we are giving to Spring Boot. Otherwise, if you don't do this, right, then there are no APIs present. I mean, if you just do a component, right? Sorry, if you just do a component, then your API here won't be present. I mean, it won't come up. It is just an indication to create an instance. But if you go back here, try to invoke, you get an error, right? So you don't have those APIs exposed. So that is what is REST controller is helping us.
Okay, thank you.
Okay. Okay. Fine. So let's move on. So yeah, between prime finder and is prime. So you know that is prime is getting injected, right? There is a different way also of indicating to Spring Boot that it has to create a singleton instance of is prime other than this annotation. That is what we are going to see. So let's say you don't have this. If you don't have this, first of all, let's understand. If you don't have this, right? If I run the server, what should happen? We should get an exception because in the prime finder, we are accepting or we are asking Spring to inject it, right? But here we are not giving indication to the Spring to create an instance of it, right? So if you do this kind of a thing and start the server, it would throw an error over here only. Okay. That prime finder required a bean of type is prime, but that could not be found because there was no indication of this. So I hope this is clear, right? Now I'm going to show you a different way in which you can indicate that Spring Boot has to create an instance of is prime. Okay. So for that, we can create a different class, call it as bean config, it with configuration, and over here we can have a public method which returns is prime, create is prime. Over here we can create is prime object and annotate it with bean. So this is the replacement. This is another way. If you don't have this component over here, then this is another way of indicating. So what is this configuration? Over here, we are telling that this class, which is annotated with configuration, is going to contain some bean definitions. It's going to contain some methods which would have this at the rate bean, and that would contain the definition of some classes. In the current case, it is having a method which creates an instance of is prime, right? So we are telling Spring this is how you create an instance of is prime. Okay, so on the startup, it would create an instance using this method. Okay, so now if you put a debug point over here and try to start it, you will see that at the startup it stops here because on the startup it needs to create an instance of is prime, right? If you release it, it has created an instance. So this is a replacement of at the rate component. So between prime finder and is prime, what's happening now? When it comes over here in the prime finder and says, I have to run this constructor, but I need to first create an object of is prime. Then it goes to is prime and sees that, oh, there is no component, right? Then it also scans this class, which is annotated with configuration and bean, and here it finds a method which returns it that instance. So it executes this method, creates an instance of is prime, comes back to prime finder and provides it here. Now, one question you might have is why do we have this separate way? I'll explain this, but before going further, any other doubts in this alternative manner which you've done?
Um, just that, like, why do we have multiple ways
Yeah,
of?
yeah, that's the next thing I'll explain. So why do we have here is see right now is prime is written by us, right? So we have all the liberty and independence to go and annotate it with at the rate component, right? The source code was with us, but imagine that this class was not with us. This class was somewhere else, written by some other person or team, and given it to us as a jar, right? Then we will not be able to go under that class and change that class or write annotation, right? And write this annotation, right? So in that scenario, what we can have a configuration class. Inside that, we can actually tell Spring that this is the way you create an instance of it. So that's why this alternative way is provided to us. That is one reason. That is one reason. Other reason could be that there are some times that there are no constructors in the inside the class. So for example, this is prime is there, right? There is a private constructor over here for some reason. And then there is a public static method which actually is creating an instance which through which you can create an instance like this. Return new is prime. Okay. So in that case, you can tell Spring that obviously we cannot invoke this, but we can invoke its 1 second. We can invoke the public method which was over here, public static instance like this. So this is another reason. So these are the different reasons why this alternative way exists.
So
Are these reasons? Yeah.
with component, we can, if even if the constructor is private, we can still use at the rate component, right?
Yeah, yeah, yeah. That one, okay. That's a different question. Yeah, we can use. If you are saying if we don't have this, right? Let
Mm.
me just comment this out.
Yeah.
You are saying that like this.
Right, right.
Yeah, we can use that because Spring actually ends up using reflection. So though we cannot use its constructor, but Spring Boot can access and create an instance out of it. Yeah, that's true.
Yeah. Okay.
Okay, any other questions regarding this alternate way of creating a bean? If there are none, I'll move forward. Okay.
Sir, actually,
Yeah.
like bean is somewhat clear to me, but not exactly like what is a bean. I mean, there is a class
Yeah.
and like class versus
Got
bean.
it. Got it. So I'll explain. So bean is nothing but the object, a name given to that object. So for example, there is an entry controller class over here, right? And we have already covered that there is an instance which gets created of entry controller. That instance, we just call it as bean. That's it. That is a Spring terminology. Similarly, there is prime method, right? There is again an instance which gets created with the Spring, right? And that object, we call it as bean. So there is what we say in the terminology that a bean is created of this class. We say a bean is created of entry controller. We say a bean got created of this prime finder. So that is the bean. Nothing but an object, a name given, a synonymous name given to an object. When somebody says that there is a bean, meaning there is an object. It's just a Spring terminology.
Is it only associated with singleton classes?
No, no, no. There are various scopes. We'll cover that. There is a prototype scope also. Bean can be singleton and bean can be prototype as well. Those are different scopes. We'll cover then. I'll just show you. But generally, bean is nothing but an object in Spring. Whatever Spring has created, that object we call it as bean. Yeah, that's what you can have. So certain
Oh,
objects you will create, right? But certain objects you are asking Spring to create. So those objects that you are asking Spring to create, those are, we call them as beans.
okay.
Okay, so this alternative way is clear. So I'll just, delete this class and I will explain other things. Okay. Okay, so now we have a simple thing. We have everything as component. Okay. Now one more thing to add, this auto add is optional. So even if you don't have, Spring understands that it has to, come here and inject. But yeah, for clarity, let's just have it. Okay, that just to show that here we are intending to ask Spring to inject. Okay, okay. Other thing is we have been injecting directly the classes, right? So for example, if you look at Prime Finder, here is Prime got injected, right? It can happen that there is a interface and then there are implementation classes and those are getting injected and we want to inject their implementation. So how to do that? So let me just go ahead and create an interface. Call it as I is prime. Okay? And we have what is prime. This is a class. Yeah, we have this method. The same method is there in this. And then this class extends is prime. Not extends, it should implement, right? Override. Okay. Now, inside Prime Finder, let's say we have I is prime. That is the interface. This is I is prime. I'm just refactoring it quickly. Okay. So now we have Prime Finder and there is an interface over here, right? And we are asking Spring to inject that. Now you know that an object of interface cannot be created, right? So there has to be some implementing class of that instance, and that object should be supplied over here, right? This is the interface. We have same method is prime, and this is prime is basically an implementation class, right? So I is prime as interface, which is starting with I, and is prime is just implementing that interface and providing that method. Now you have it annotated with component, right? So it's pretty straightforward that for Spring, it will go and check this is an interface and there is only one implementing class which is implementing it, which is prime, and that is annotated with component. So it will go ahead and create an instance of that and it will inject it over here. Okay. So if I stop and run this, and also let me put a debug point here and start the server. You see on the startup, if you see the class, what got injected is prime, right? So that is this implementing class that we're talking about, right? So that got injected over here. So if I release this, this will just go and work all fine. Your application should work. It's working, right? So this is how we inject a implementation class when you have an instance and when you have its implementation class. Now things get ambiguous when you have multiple implementation classes. So right now we have an interface and we just have one implementing class. We can have two also, right? We can have multiple also. What happens there, right? So that is what next we will see. So we will create one more implementing class with this. Okay. So what happens? Let's say there is a colleague who comes. Just excuse me. Okay. So there's a colleague who comes to you and says that checking the number that it's a prime, it's a very expensive operation, right? Overall flow itself is very expensive. Let me show you how. In the prime finder, we are accepting a number, right? Input. Let's say the input is 100, right? And internally, what we are doing, we are having a loop of this, which will iterate through 101, 102, right? 103, and it will keep on iterating until it finds a prime number. And how it internally finds a prime number? For each iteration that it is doing, it would run a loop from 1 to that number, right? So for this one, it would run a loop from 1 to 101. For this number, it would run a loop from 1 to 102. For this one, from 1 to 103. That is happening inside that is prime class, right? Over here, right? So this is an expensive operation. To show you, let me give you a very big number over here and see. Let me give more big. Yeah, if you see now there is a certain delay. Let me close the window and you see, yeah, here it is loading. The loops are running and now the output is present, right? So overall, it's an expensive operation, right? So one colleague comes in and says that uh, we can have a different implementation of this, which would be very fast and which would use a cache. So generally what we are doing is we are basically having is prime class. Inside that we are checking is prime number, right? But it can happen very well that repeated numbers are being checked. I mean, once we get to know that certain number is prime, then why do we need to again check it? We can store it in our cache, whether it was prime or not. The next time when that request comes in, we can return it from the cache. So that kind of implementation class can be written, and I'll do the same thing over here. I will say is prime, cacheable is prime. Okay, cacheable is prime. Yeah, so I've just copied is prime as another class, which is cacheable is prime. And over here, I can have a map which will hold a number and a boolean. Let's call it is number prime. Okay. And once this method starts, we will check if my cache has the number. Then I just simply go ahead and return that. Right? And if I don't have, then I run all this logic. But before returning, I can note down what the result was. Like this. So this way, there is a cache. So this way, if a number is checked once, we always have it in memory. The next time you run, it would just return you very fast, right? So I hope this implementation is clear, right? Why this would be fast because we are having a cache, right? Is this clear? This logic? Someone
Yes.
guys, yeah. Okay. So then, yeah. So now there is a problem that there is this interface, and then there are two implementation classes. One is prime, and the other one is cacheable is prime, right? Let's say you want to use one of them, right? We have been using is prime, so your team decides that we don't want to use this now. We want to switch to cacheable prime, right? So to do that, we say that one simple way to do that is let it be annotated with component, and from this class you can remove this. Okay. So this is an indication to Spring Boot that it will only create an instance of cacheable is prime. It will not create the instance of is prime, right? So when Prime Finder is running, it says that there is an interface whose some implementation object I need to inject here. It will go and check what are those implementation. It will check there are two implementation, right? And only one is annotated with component. So it will only provide an object of cacheable is prime over here in the Prime Finder. If I put a debug point and restart the server, you would see over here the object, right? This cacheable is prime is getting injected, right? And let me release it. And let me also show you the effect of it. So for example, this kind of a request takes time, right? Let me run it. It is taking time as you see. But once it is done, now it is done, it has everything in cache. So the next time if you try to run the same object, it should be fast. See, it's fast, right? Because so your another implementation actually is being used and that is fast over here, right? So this is one way where you have got an interface and you have got implementation classes, and one of them you want to choose, you can choose like this. But there is a problem in this approach. The problem is, see, if you have chosen this and if you have deployed this application on production, and if there are problems, and there can be problems, see, this performance is coming to you, but this is coming at a cost of cash. If the client is actually, checking big numbers, and those big numbers almost happen to be same every time. So for example, this number is being checked multiple times, then this kind of implementation makes sense, because they are checking big numbers, and that too only few big numbers they are checking. So the cache can hold that data, that is a small data, right? In that case, this implementation makes sense. But if the client starts to check a lot of other numbers, small numbers, big numbers, and a lot of range of numbers, right? Then your cache can be blown out of proportion. This could actually impact the memory, right? So in that case, this implementation is not suitable, and the other one is suitable, right? So suppose your application went and it started using cacheable sprint, right? And on the server, you realize that it's not going fine. You looked at the metrics, you see there is a lot of memory issues because this cache is just growing, and you want to switch to this is prime, right? Then there is no way you can do that, because no way in the sense, like, what you have to do is you have to again do code changes. You should come here and again uncomment this, and then comment this one, right? And then merge your code, let all the deployment start again, and then only the implementation class would get switched, right? So this is a lengthy process, right? So is there a way we can do it on the runtime? Yes, there is a way. Spring provides you a way in which you can on the runtime, switch between these two. Okay, how it happens? Let me show you that. Okay, so so basically what we will have is we should have some kind of a configuration in place. I'm going to create a class which is application dot properties. Okay, is okay. Okay, I wanted to create application dot properties, but one second. It's got created in a wrong way. One second. Create a file application. Yeah, application dot properties, right? So over here, you can specify, first of all, based on any kind of a flag, that what do you want, which implementation you want, basically. Okay. So let's say that I am saying that prime checker or prime checker implementation, right, is equals to cacheable. Okay. And then the second, so here we are configuring a flag, right? And let me show you how these flags should be used. So you have got is prime. It should be annotated with this, and we should say it's a conditional on property. Okay. Value. Value is what we have specified here. Once again, application dot properties, which is this. We say if this property is having a value simple, then Spring Boot should create an instance of is prime. Okay. So this is the meaning of this. Similarly, we will go to other class, which is cacheable is prime. Over there also we'll annotate it with component and say that there is a condition where you have to create this. And here you can say cache. What we have specified in the application dot properties, cacheable, right? So we should specify cacheable, right? So this is the flag prime checker INPL, which is configured in the application dot properties, right? And we are configuring our classes in such a way, we are saying Spring Boot that you should conditionally create the instance of either one of these classes based on this, right? So is this things, are these things clear how we are configuring these things in the application or properties and how we are making the use of them?
Yeah.
So in the current case, if we have specified cacheable, then what will happen? cacheable is prime instance is going to be created and going to be injected over here. Even if I restart the server, you would see, put a debug point here, you see a cacheable is prime instances getting injected, right? And if I change this property, let's say to simple, right? And then restart the server, you see that other class, which was is prime, the instance of that is getting injected over here. So in this way, by controlling a property, we can switch the implementation, right? We just change the property and so the implementation gets switched. So this is one way of choosing one implementation. Okay. So is this concept clear of switching between the implementation?
Yeah, but on production,
Yeah.
we will not be doing these things, right?
Yeah. So on production, what happens? There are some other things as well into action. So basically, what happens is this property, right? This can be changed on the production. How it can be changed? Here you see that in the source code only I have provided this, right?
Yeah.
But when it is deployed on production, if you have an environment variable of this type, right, and you change that, then the application would actually refer that environment variable. So on the
Without
runtime,
needing to bounce.
Yeah. So there is a different process. So the what happens is that there is an instance of application which is running, right? So what would happen is when you change this property, right, you have to restart the server. So
Okay.
over there on the environment, what we do is that we change that environment variable, right? And then we start a new instance of the application and shut down the old one. But this
Okay.
all happens in a way where the client does not faces any runtime. So one is coming up like a blue-green kind of a deployment. One is coming up, the other goes down, and it switches the flow of the client's request from one to other. So in a way, you do not have to, change your source code and deploy everything. This all happened on the runtime only for the client. Client did not know anything, right? So
Okay.
the response to the client is fast. I mean, we changed the implementation in a very short time. We did not have to make any code changes in that way, right?
Got it. Got it.
Any other questions, Samta, Anshika?
But the cache, whatever we are doing, right?
Mhm.
The values getting stored will anyway get flushed out on restart on the
Which
server,
values?
right? The values which are cached on the server. Suppose we
Um,
are using the cacheable implementation, right?
yeah, yeah, yeah.
So once you restart or bounce the server, all that data will anyway be lost.
Yes, so when the server starts, it reads those things. So right now in the application dot properties, whatever you mention, it will read those. But if there is an environment variable available with this name, then it would prefer that. It would actually, read that one. So on the
Okay.
production, that's what happens. Your source code would have one. But when the instance is coming up, we will have an environment variable also, which we can modify on the runtime. And application would refer to that and would act according to that. So this is
Okay.
little bit
Look
outside of, yeah.
about the map, that cacheable map that we have
Yeah,
created. Yes, that will get, uh, you know,
flushed out.
yeah, right, flushed out.
Oh, yeah, this one you are saying. Yeah, yeah. So
Yeah.
on every, yeah, okay, okay. I did not get the question. Yeah, yeah, fine. This will definitely get plus notice. Okay.
Okay. Yeah.
Okay. So so this is another way in which we can have. There is one more way. So let's say that there is a different scenario in your project. Okay. So there is a scenario where you are we have configured it to be cacheable. I'm getting rid of this because I need to explain something else. I'm getting rid of application properties and these kinds of annotations as well. Okay. Okay. So now there are two implementation again, right? Now there is a situation where it is decided that in this prime finder, we want to inject an instance of is prime only. Okay, because the clients are checking large range of numbers, right? So it is not possible to maintain that kind of a cache, right? So that's what the call is taken in routine. Okay, but there is a different flow on the same time, which is a different endpoint, right? Over there, clients are, for some reason, clients are actually checking big numbers and that too only few numbers, right? So for that new flow, the cacheable is prime can be used, right? So there is a situation in your application that there is an interface, there are two implementation. One implementation has to be used in the current flow, which we are coding, that is Prime Finder, and the other implementation has to be used somewhere else. Okay, so this is the requirement, right? So how we will do that? In that case, both will be annotated with component, right? And we have to inject only one here, right? So in this case, if you just restart the server, it would again give you error because it is an ambiguous situation for Spring Boot. It does not know that what to inject here. We have actually annotated both of the implementation classes to be component, right? So it does not know what to implement here. And if you just start with this, you will get an error from Spring Boot. See, there is an error, right? So we need to tell, we need to point. Okay, so how to do that? We can do that by giving these beans a name. Okay, so let's say we can give any name which we want. I'm just typing something like is prime. Okay, so what we are saying that uh, we are allowing, we are actually giving an indication to Spring Boot that go ahead, create an instance of this, create a bean of this, and name that as this one, that is prime. In a similar way, we can name this as well, which is cacheable is prime. Okay, you can name anything. Okay, and then we can come here and say when this is getting injected, I want the bean with a particular name whose name is prime, because that is what I intend to inject here. There would be another flow where another instance that is cacheable is prime would be needed, and over there qualifier of cacheable is prime should be used. So if I restart the application and put a debug point here, you see an instance of is prime got injected over here because we indicated to Spring Boot that the ambiguity has to be solved with this qualifier, right? You've got different beans, but there are names of those beans. Go ahead and inject that bean over here. If I release this, it gets injected like this and things should work over here. You see, it's working well, right? So is this usage of qualifiers clear? This is a way in which we can give the beans some name, and the use case is this only, that when you have different kinds of different implementation, right? And you want to use one implementation at one place and a different implementation at the different place, then this is used. So is this clear? Samta, Anishka, Karthik?
Yeah, it's clear.
Yeah.
Yeah.
Okay. Okay, good. Then the next thing is modes of injection. Okay, so this is a small thing. Let me show you. So let me get rid of this now, qualifier thing. And let me also get rid of naming these.
Section
And
for
and let me also, cacheable is prime is not needed. I'll just delete it. Okay, because these concepts are clear. We just have a simple thing where there is an implementation, there is an interface, and then it is implemented. Even actually, this also I don't need to explain the next one. So let me go ahead and delete this also, so things are more clear to you. We don't need to implement this. Just a simple class, no overriding. The prime finder you have is prime. Okay, pretty much same thing which we had some time before. Okay, so prime finder is just having a dependency on this prime, which is annotated, and it is getting injected. Okay, so this is the constructor injection. That means that we are asking Spring to inject this in this constructor, right? So this is called as constructor injection. There are few other ways how you can inject this. one, I'll comment this. You can directly come and say on the field that auto wired it, right? So in this also, Spring will actually provide this over here. If you restart the instance, it should get injected over here, and our flow should work all fine. You see, it's working fine, right? So this is another way of injection field, right? There is one more way which is called as method injection. So in that, what happens is you do not have auto wire over here. You have a setter which sets, and over there you call this auto wire. So Spring, what it would do in this case is, first it would create an instance of this because there is no constructor, right? So I told you there is no constructor introduced by us. There is a default constructor which is available from the Java itself, like this, right? So it would call this to create an instance, and next it would call this setter, which is annotated with auto wire, and provide the dependency over here, and our flow should work as usual. So whatever was being injected to constructor is now injected via this method. You see this works fine, right? Now, with all these things present, what should you use? Basically, you should always use the constructor injection because that is the most good best practice, because the general understanding is that once you have run constructor, a full blown object is ready. You should not use the, imagine if you're using this, right? In the UT, if you are writing, you instantiate an object of prime finder, and then you are confused whether I should call this setter or not, whether it's a full blown object or not, right? So this is not the right way to set the expectation of the users of this class. The general understanding is that inside the constructor of this class only you do everything, so that anybody who uses this class, if they just use the constructor of it, they should have a full blown object of this class. So that's why you should always use constructor. Away. Yeah, I will remove the other things. So these different ways of injection are clear.
Yes.
Okay. So now there is a small code that I will show you, and there will be something wrong about that. And you just try to see, analyze, and see whether what is wrong. And then there is a next thing also that is also very less. So we just have one more topic to cover. And to do that, I basically need to create another class. So let's say there is a new requirement. Okay. The requirement is we need to create a controller. We need to create an API that should return current time. Okay, that's a simple thing, right? So our developer comes in and creates a class called as time, right? And basically, yeah, he or she writes this code. We'll understand its bits and pieces. Let me note all these things. Yeah. So developer creates this class, time class, and says there is a get method inside this. And there is a mode also, that is time zone mode, which is set to Indian. That is, with this, we are setting to India time zone. Okay. So if somebody calls this get method, we by default have Indian time zone, and we return that current time in this format. Okay. And if somebody wants in a different time zone, then they should first set this kind of set this time zone, right, to something else, whatever they want, and then they should call this get method to get the current time in that particular time zone. Okay. And the developer says it can be annotated with component and can be injected in your controllers, right? So this logic is clear. This small logic, which is we are just invoking, getting the current time from the Java APIs. That's it, in a particular time zone. Okay. Let me create a controller now, which would be responsible to expose that new API. Let me import everything. This is nothing but a small class which actually uses that. Okay. So we have here a controller, time controller, right? Where we are injecting the time, right? Because we need to invoke a method on it. And then we are exposing an API, which is time. And along with that, we accept a time zone parameter also with the client, which they can send. And whatever they send, we check whether the time zone supplied by them is US. If that is so, then we set the time zone to US. If the time zone is India, then we set the time zone to India, and then we call the get method on that. Okay. So let's run it to see if this new endpoint works or not. Okay, so new endpoint is time, and we should supply time zone. Time zone can be by India. If you see, this is the time, right? This is the Indian time, right? You can also supply US. It would give you the US time, right? Let's check what US time is now. Yeah, 3, 4 a.m. It's giving you the right US time, right? So this is working in this way, right? So can you see this code and see if something is wrong or something can go wrong in this particular flow? Just take 30 seconds or so to analyze this. I'll give you a hint. The hint is the time object is singleton over here, right? So every time we are using a singleton object and setting various kinds of mode and then calling get on it. That's your hint. Just see what is going wrong and then we'll fix that. No guesses?
We should
Okay.
have
Mhm.
else if other
Oh,
than
okay. That's okay. That's one thing. That's a different thing, not that. So let me tell you what's wrong with this. The thing is, we are using a singleton object, right? And a US request is coming and setting some time zone, that is US time zone, and an Indian request is coming and setting Indian time zone, but on the singleton instance. So there might be race condition, right? Imagine, take an example. Take an example that a US request came, right? So US request will come, code will execute, this if will execute, right? This would execute and set the time zone as US time zone. That's fine. Now let's say here the execution is waiting. Waiting means, I mean, it's running, but let's assume that there is some kind of delay. Meanwhile, another request came in, which is Indian request, right? It came, it would not enter this if block. It would enter this one, right? And would set the Indian time zone on the same object, right? And then the Indian request would give you the Indian time back. But if you talk about the US request, when it resumes the execution flow, it would not go under this if, and it would also end up giving you US time. To demonstrate that this problem, let me introduce a sleep over here, which is red dot sleep. I will sleep for 20 seconds. Okay. So what will happen? I will send first US request. US request would come here and here it would get stuck. It would start taking time. And as it is taking time, I will send another request which is Indian request. That would come and would not go under this, would go under this if block and would set the time zone to India. But remember, it's the same object on which we have set the time zone to India. There is just one single object out there, right? So we end up setting the Indian time zone and the Indian request, whatever we are sent, that over there we will end up returning Indian time. That's fine. But the US time, but the US request, when it resumes the flow, it would also get the Indian time. Let me now show you from the uh, browser. So first I will send US request. Let me close all this. Yeah, first I will send US request. See, it started taking 1 second. I think I did not restart the server. Let me restart. Yeah, server is restarted. And now let me send a US request. See, it started taking time. Meanwhile, I will send Indian request and it returns me Indian time, right? But now see the US time. It is taking that 20 second because it is waiting there. And once it finishes, we should see the output. Yeah. See, it is again returning you Indian time. So that's the problem with this code. Is this problem clear? This race condition that I had explained. If this is clear, then there is a simple fix that we'll do, and that's it. Is this race condition clear? Karthik, Samta, is this race condition clear? Is there any doubt? You can ask. I'll explain more.
Can you show once the browser again?
Yeah, sure. By sending the request.
Yeah, yeah, right.
Okay. So the thing is, we are sending US request, right? Started taking time, right?
Mhm.
Meanwhile, we are sending Indian request. Indian request got served fine,
Yeah.
but US request, if you see, it's taking time
Mm-hmm.
because it's the same object, right? That on that same object, that Indian request has already set the time zone to India, right? And that's why over
Yeah.
here also we get this. So if you look at the code, let me explain once more. So first time US request comes and it executes this, sets the time zone on this time object to be US, and it starts waiting here, right? It is waiting. Now meanwhile, another Indian request comes in. It will not go under this block. It will go under this block, right? And it would set the time to India, right? And it is the same object on which earlier the time zone was set by US request to be US. The same object is used here, right? So on the same object, it has ended up in setting another time zone, which is Indian time zone, right? So that's the problem. That's the race condition between these two requests, right? If you are using the same, if you are using such stateful objects on which you set these kinds of modes, right? And there is a singleton instance present over here, right? So different requests can actually come and modify that state, right? And that's how they can interfere with each other, and that's how the bugs could be there. So is
Yeah,
this
so this
race?
is yeah,
Mhm.
this is just one case, right? With singleton, there is so many other possibilities which does not work. So in all those cases,
Yeah.
we will have to ensure, right, that
Correct. Yeah, so this is one example that I'm showcasing. What
mm,
could go wrong if you're using singleton, right?
yeah, yeah, yeah.
Yeah. So if this race condition is clear, then I'll move to the solution. Samta, is this clear? The race condition, the problem basically which we are having.
Right.
If there, right? If there is any problem, you can ask. I'll explain again.
No, it's fine.
Right? Okay. So all in all, I'll remove this leaf. All in all, basically, why this is happening is because this is a stateful object, right, on which we are operating. And if you are having stateful objects, I mean that this is maintaining certain mode inside it, which is time zone, right? Now, Indian time is coming and modifying the time zone to something else, and US request is coming and it is modifying it to something else. That was the problem that we saw when we have singleton instance. The solution to this could be that you do not have a singleton instance, you have prototype kind of a instance. So this is another scope. So somebody was talking about the scope, right? So this is another scope which is called as prototype scope, meaning that Spring Boot will not create the instance of time only once. It will create the instance of time every time the instance of time is needed or asked for. Okay, so every time it will create a new object of time. If that happens, then our problem gets solved, right? Because then US request would come in and it would create a new object of time and it would set the mode on that object and get the current time from there, right? And similarly, when the Indian request comes in, it would create a new object of time and it would set the time zone over there and it would be able to get the time from there, right? In theory, is it clear? In code, how we'll do, I'll explain. But in theory, is this clear that if we create every time a new object of time, then this problem gets solved, right?
Yeah.
It will be created per per HTTP request or
No. It is create. It will be created every time we ask. Every time our application asks to create. So right now, if you see, we are asking it only once. We are asking in the time controller, right? When Spring runs, right? Spring Boot runs, then this constructor gets executed, and over there we are asking once, right? So when we move to prototype scoping, that means every time when we ask, and right now we are asking once, but going further, I'm going to ask multiple times. I'll show you how we will do that. Okay.
oh, yeah.
It's not per request, it's like per time that we ask for. That the one which you are asking, that's a request scope, and actually that is not relevant to the microservices as such, because that is relevant in Spring MVC, where there is a view layer also. Okay.
Mm-hmm. Yeah.
So
Yeah.
over here there are just two scopes. One is singleton, one is prototype. Okay. So now let's see how we can do. What we need to do is in the over here we can come and we can say scope prototype. That's it. When you don't have this, I mean earlier I was not having this, right? Then that was equivalent of saying scope of singleton. Okay, so when I was not having anything, then it means that this was there. So if you want to have prototype, you should explicitly say that I want a prototype. So declaring this is an indication to the Spring Boot that every time the object of time is needed, I will create a new object of time. Okay, so this is one thing that we need to do. Now, if using this also we, start an instance, then also the problem will not be solved, because though we have actually told Spring that every time an instance is needed, you should create a new object. But how many times we are asking Spring to create an object? Only once, right? Because we know that time controller has a singleton object, right? So this constructor gets executed only once at the startup. And that is the only time when we are asking for the time object. Right? So only one time we are asking. So Spring gets to know, okay, fine, you are asking me first time, I'll create you a new object and give it to you. Next time we are not asking, right? So the problem which we saw, the race condition remains as is. It is not going to be solved. Okay. So what is the way to ask every time whenever a new request comes in? What is the way to ask Spring Boot to create an instance? The way to do that is that we should have an object factory here. Object factory of time. Okay. And in the constructor also, we should have an object factory like this. We can say this as time factory, time factory. Okay. And over here, what we say, time is equals to time factory get object creates. Yeah. So like this. So if you see here, Spring provides this basically object factory is under the Spring. So we are saying that, on the startup, give me an object factory, which is a singleton. I mean, that is fine, right? But every time a request comes in, I will ask that factory to produce an object, a fresh object every time. Okay, so this is how a new object can actually be produced every time. So let me show you, let me put a debug point here and restart the server to make you see that every time it creates a new object. So let me send a request, this one. You see, and if you see, breakpoint has stopped, and the object is having the ID of 5928, right? Now I'll release this. I will send another request. If you see, it is 5980, which is different one, right? So every time this method is getting executed, we are getting a new object out of this factory. And that is how the execution is happening, right? So now with this, our problem should get solved, even if you include this sleep here, which I had. Let's sleep for 20 seconds and see if that problem goes away or not. Because now every request is creating new object, setting a mode on that, and then getting the current time, right? So now let's try to reproduce that problem. I send a request to US. It started, uh, it stopped here. Let me release. It started taking time over here. Meanwhile, I'll send Indian request. It returned me Indian time. Let's go back to the US request and see what's happening. It should also now return the correct time, which is the US time. Okay, if you see, it has written you, one second, there is something wrong. Yeah, it has written you US time, right? So this is how, this is prototype scope. This is how we actually, can create an object on demand every time. But remember that, most of the time your work would be done with the singleton object only. The best practice, first of all, is to have stateless objects. This time, if you see, we had created a stateful object, right? This itself is not a good practice. But for some reason, if you have such a case, you can have prototype scoping. Otherwise, you should always use singleton, because singleton is a way where you have less kinds of objects in your heap. Right? You are not polluting too much. If you had to make this time as singleton, I mean as stateless, then instead of having this time zone as being set here in the setter, you should actually accept this over here like this, right? And remove all this. So client, then this becomes stateless, right? Because then there is no setter which is allowing, even the time zone is coming in the method itself. And then you can use the singleton class of the time to make you work, right? But how it calls, I mean, it should call, the controller should actually start passing the time zone over here, then things would work. But this was just a demonstration to show you that in case you have stateful application in your class, in your application, then prototype scoping should be done. Okay. So is this prototype scope clear?
Yeah, but that defeats the purpose of singleton, right? Like every time if it's creating an object, yeah, there might be a
Yeah.
requirement. But
Yeah.
then if it's a large scale application where huge number of requests are coming in, it keeps creating an object every time.
Yeah. Yeah.
And that defeats the overall purpose, right? Like
Yeah.
why?
Defeats the overall purpose, meaning like, see, the howsoever our application is Spring is a framework, right? It just gives you
Hmm.
different ways you can
Okay.
use. Even when I have used Spring Boot, most of the times it's singleton only. It's
Hmm.
just that they have given you some more
There's
facility.
options.
Yeah, there
Hmm.
are options, and you can
Hmm.
use those options. Sometimes it can happen. So suppose this time was actually given to you in a third party library, not in your application, right?
Hmm.
So you
Hmm.
cannot, modify the code to have a stateless
Correct.
object. Then you need to deal with that only, right?
Right.
So that way they have given.
So while building, you need to like remember all this and make the best use of whatever we have.
Yes, yes. The best practice is if you are writing a class,
Hmm.
try to use singleton and try to create stateless objects.
Got it.
This object factory is also maintained by Spring.
Yeah, yeah. If you go there, if you see Spring Beans, it is under the Spring. There's an interface which is there. So
Mm.
we just need to use that over here. And it injects an implementation of that interface. And when you use that get object, you will get your object back.
Is it based on the same factory pattern that we have, right?
Yes, yes, yes. Yeah, so it's in factory. So basically, its descendant is created on the startup. Okay, so a Spring Boot, what it does, when you have this object factory of time, right? It would
Mm.
create an implementation of this, and which would have a method of get object, and that would be giving you the object of time. So
Okay.
behind the scenes, it does all those things. Okay. Any other doubts so far? Anywhere? Anything else you want? Okay. So actually, that's all I had to cover. So I know Karthik actually, but Samta, can you introduce yourself for a while? I mean, are you a working professional or?
Yeah, I am working professional. I have used Spring Boot a bit, but like recently I was totally out of touch of it, so thought of taking this session,
Okay, okay,
which was certainly a good recap of things.
okay, okay. Yeah, sure. Okay. Okay, so for today I had this much only. If at all, I'll also be planning some more sessions on Spring Boot and other things as well. I'll keep on sharing for these short sessions where everybody can benefit. Okay.
Yeah,
Hope you like the session. If there is any feedback or something, just let me know here or on the message so I can improve myself.
yeah, sure.
Right.
It was a great session. Maybe
Okay.
next cover more topics on Spring Boot itself. So that will like make it a full-fledged course itself. So will
Yeah,
be
yeah.
helpful.
Yeah, sure. Sure, I'll try to do that, but it would be divided into modules. So today we
Yeah.
covered DI, then module by module we can go and cover it. Sure.
If you can cover Spring Data next whenever
Okay.
possible, will be great.
Sure. Sure, sure. That's a good thing.
Yeah.
Okay, fine. I'll try that. So, by the way, tomorrow I'm going to my hometown where internet connectivity is not so good. And I'll be returning on 24th. So definitely after that, I'll share on my LinkedIn, and maybe from there you guys can pick up and see. Right?
Or you can share on the WhatsApp group as well. That will
Sure,
also be
sure.
helpful.
Sure, I'll share there as well.
Okay. Thank you so much.
Yeah, it,
Okay.
it was a very well presented session, Sandeep. Thank you so much.
Thank you, Karthik. Thank you. Thanks a lot.
Thank you.
Okay.
Bye.
Thanks. Yeah. Thanks for attending. Have a good day. Bye bye.
Thank you. Bye.
Bye.